Coming to the next situation, when do we have coincident lines? Now, before we begin coincident lines, I must tell you that when the lines are intersecting, we have one unique solution. We have one unique solution, only one point where the lines are intersecting. Now, when we have coincident lines, then A1 upon A2 will be equal to B1 upon B2 will be equal to C1 upon C2. That means all the coefficients, the ratio of all the coefficients will be equal, and in this case, there will be infinitely many solutions. If we solve it algebraically, we'll see that there are infinitely many solutions to this set of equations. So, in the given example, if we have two set of linear equations, 3x minus 4y minus 8 equal to 0 or 6x minus 8y minus 16 equal to 0, if we have these two equations, let us check what is A1 upon A2. A1 upon A2 is equal to half. Again, see, B1 upon B2 is equal to half, and C1 upon C2 is also equal to half. So, from here we see that A1 upon A2 is equal to B1 upon B2 equal to C1 upon C2 is equal to half. And as such, if we plot both the lines, I can see one line lying over the other, and it's a case of coincident lines. Now, parallel lines. Coming to parallel lines, if A1 upon A2 is equal to B1 upon B2 and but not equal to C1 upon C2, just look at the difference. In coincident lines, A1 upon A2 is equal to B1 upon B2, which is also equal to C1 upon C2. Here, A1 upon A2 is equal to B1 upon B2, but not equal to C1 upon C2. Let us understand this with the help of an example. Here, we will have inconsistent pair of linear equations, a pair of linear equations which has no solution because the lines are neither intersecting nor coincident. So, if we have two such situations, the first equation x minus 3y minus 6 equal to 0, the first set of equation, the second equation 2x minus 6y minus 5 equal to 0. Let us check it ourselves. What is the ratio of the coefficient of x? 1 upon 2. What is the ratio of coefficient of y? 3 upon minus 6 is equal to again 1 upon 2. So, we saw that A1 upon A2 is equal to B1 upon B2. Now, let us check it with C1 upon C2. C1 upon C2 is 6 upon 5, which is neither equal to A1 upon A2 or B1 upon B2. If we plot these lines, we'll get a pair of parallel lines. So, let us recall what we have learnt. If the lines are intersecting, then A1 upon A2 not equal to B1 upon B2. If the lines are parallel, then A1 upon A2 is equal to B1 upon B2 but not equal to C1 upon C2. On the other hand, if they are coincident, all three ratios are same, A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Now, let us quickly go through the key points. Two linear equations in the same two variables are called a pair of linear equations in two variables. The general form of writing a pair of linear equation is A1x plus B1y plus C1 equal to 0. The first equation in same variables x and y, and the second set of equation is A2x plus B2y plus C2 equal to 0. Where A1, A2, B1, B2, C1, C2 are all real numbers and A1 square plus B1 square not equal to 0. The same with A2 square plus B2 square. The graph of a pair of linear equation in two variables is represented by two lines which may be coincident, parallel or intersecting depending on the ratio between the coefficients. If the lines intersect at a point, then the point given has a unique solution, and we call that the set of equations are consistent or the lines are consistent. If the lines coincide, then there are infinitely many solutions and each point on the line is a solution. So, there is no unique solution, and this type of the pair of equation is still consistent. But if the lines are parallel, then the pair of equation has no solution. In this case, the pair of equation is inconsistent.